Hi guys, so before we get started with today's lesson, I want to go over what do we mean by an equal sign. So it's the most used sign in math, but sometimes we forget that it's also the most important one. Well, here I have an equal sign represented. An equal sign means whatever I have on the left is exactly equal to what I have on the right. So here in the yellow, I'm going to call that y, whatever I have in there. And whatever I have in the red, I'm going to call that r. So we know these rules pretty well. If we're solving for an unknown, or if we're manipulating an equation, we know that we could add something, plus let's call it x. If we add something to one side, well, if we want them to be equal, we have to add the same amount to the other side. And then they're equal once more. So we could also subtract y minus x, and so we'd have to remove the same amount. So what I have in y, I take some amount of x out, and I have to take out the same amount from the red to again make it equal. I could also multiply 2 times the amount in y is going to be equal to 2 times the amount in r. So I'll multiply them both, and it'll still be equal. Same thing with dividing. So these are the rules we know and love. And when we have an equal sign, it means whatever's on the left is the same as whatever's on the right. So we have, in this case, a balance. So something new for us will be, what if we don't want or we don't care about equals? What if we want them to be not equal? In fact, that's the title of today's lesson, inequalities. So not equal. So for that to happen, that means, in this case, that whatever's in the yellow is greater than what's in the red one. So we're going to have always more weight on this side compared to the other. So is there one answer that satisfies this? Well, let's see. Let's find some values for r. Okay? How about 100 grams? Okay, it could be 100 grams. And this works. The right is still less than the yellow. Okay, so 100 grams works. What about 200 grams? Okay, so r can also be 200 grams. What about 400 grams altogether? R could also be 400 grams. What else can it be? 450? 500? 550? Okay, so I've reached a point. It cannot be greater than 550. So in fact, here, y is greater than any value greater than 520. So y is a value just greater than 520. In this case, I just measured these out, and it's just over 520. But we could have a case, if it was exactly 520, then we have another type of inequality where we could say y would be greater than or equal to, let's say, 521. So this is what we're talking about today. There are multiple answers for these, and we have to find a way to find solutions for these inequalities. Again, we're not going to be using an equal sign here because an equality is when all things are equal, and inequality is when things are not equal. So, in math, it's when one side of an equation is tilting towards another side, a specific side. So just like we saw with the balance, one side is greater than the other side, meaning one side is less than the other side. So here, 4 is obviously quite a bit larger than -3. So we say -3 is less than 4. So that's clear to see as soon as you put it on a number line. And my first big tip for you in all of these is whenever you get confused, whenever you're not sure, make a number line. A number line clears everything up because you can visually see which one is greater than the other. So it's not too important when you have a number like -3 and 4, but when things get more complicated, when there's algebra involved, a number line can really, really help things out. So let's go over some symbols as my camera focuses. So the first one, or sorry, the first pair, simple enough, your less than or greater than signs. So these symbols, they use an open point when we draw it on the number line, which we'll see here. So here I have x is greater than -3. So how am I going to draw this? An open point means this point is not actually on the number line. Notice that x can never be equal to 3. It always has to be greater than. It could be, 0.1, it could be 0.000001, it could be any number that is just even a little bit bigger than -3. So the way we draw this, it's any number from there all the way up. So remember, there's multiple possibilities in answers, and this is how we represent that on the number line. So if this was our solution, x could be any number along this number line greater than, but not including, -3. So this sort of open dot shows that this is not included. The other way these things, before I continue, how do we write this interval? Well, first of all, it starts at -3, and -3 is not included. So we're going to draw square brackets facing away. See, the square brackets are facing away from the -3. And how far does this go up? Well, all the way to infinity. And there you go. There's our bracket. So our next set is your less than or equal to and your greater than or equal to. So here we used a closed point, meaning a real solid dot. So here x is less than or equal to 0. So it starts at 0, and we're going to use a solid dot because 0 is included in this interval. X is less than all of this, less than 0, so our number line goes downwards. So here is our situation represented on a number line, and here the interval, we include 0, so 0 is included, and we go downwards, so 0 is included, and it's to -infinity. So there you go. So this first part here is about solving one-dimensional inequalities. One-dimensional means we only have one unknown. So we don't have an x and a y, we just have an x or a y or any unknown. So there's only one of them. So how do we solve these? Well, we solve them exactly the same way we would solve an equation. The same rules apply, reverse bed math, try to isolate the variable, but instead of an equal sign, we have our inequality signs. But the movements are exactly the same, the math is the same for the most part. So here's an example. 4x minus 7 is greater than -2x plus 5. So how do we solve this? Well, we just move along as we would if it was an equal sign. We bring the -2x over. We continue until we have a completed answer. So here our solution is that x is greater than 2. This means, and if you go ahead and draw this on a number line, 2 is not included in this solution. It's an open point, not included in this solution, but any number greater than 2 is. Any number greater than 2 will satisfy this solution, and we can check that ourselves. So since x is greater than 2, any number greater than 2 will work in the original inequality. So, will 2 work? No. But any number greater than 2, absolutely. So here is our set of solutions. So try out a number for yourself and see if it works. Our original equation was 4x minus 7 is greater than negative 2x plus 5. I want you to go ahead and try any number greater than 2 for yourself and see if this works. For myself, I'll just use 3. So 4 times 3, putting 3 in for x. Let's see what we get. (12 minus 7 is 5. And negative 6 plus 5 is negative 1. And in this case, 5 is indeed greater than negative 1. If you try out 2 for this equation, you'll find that it does not work. So, important note here. This is very important. There is one important difference between solving equations and inequalities. The direction of the inequality sign may switch under 2 conditions, meaning we might go from up greater than, and then as we work down, it might become the other way. Sorry, a less than to a greater than, or vice versa. So there are 2 situations where this could happen. The first is if you switch sides entirely. So try this equation. If for whatever reason you want to switch the sides completely, so bring whatever's on the left to the right and vice versa, well then you'd have to switch the inequality sign as well. So that should make good sense to you. The one that might seem new to you is if you multiply or divide by a negative number. So again, if you multiply or divide by a negative number, this is like turning the scale around. So remember the scale that we saw at the beginning, yellow and red? Imagine multiplying or dividing by a negative number is like turning it 180 degrees, so switching the sides. So if we switch the sides like that, then we need to switch our inequality sign as well. So here's an example. Negative 2x is greater than 4. Well, if I want to solve for x, I'll have to divide both sides by negative 2. And when I do that, notice that I switched the direction of the inequality sign. And this works, so x is a number less than negative 2. You could double check this for yourself. Try a number that's less than negative 2. How about negative 3? Negative 2 times negative 3 is 6. And so the inequality holds. So the rule is if you multiply or divide by a negative number. So that's the end of the one-dimensional inequalities. Now we'll move on to two-dimensional inequalities. So this is the most common type that we're going to see. So here we're talking about our old friend, a system of inequalities. That involves 2 variables, usually x and y, but we can call them anything. So all you need to do is get both of your equations into function form. And you're going to see why this is very, very helpful in a minute. So everything you know about solving a system of equations still holds, but I'm telling you, you're going to make your life a lot easier if you can turn everything into function form. So take a look at what we have here. Just look at the graph for a second. Suppose we had the equation y is greater than 3x minus 2. So Okay, but before we actually solve a system of equations, let's just go over exactly how do we represent an inequality which has two variables on a graph. Well, one, we need a graph, not a number line, because now we have two dimensions, an x and a y. Take this example. Y is greater than 3x minus 2. Greater than, not greater or equal to, just greater than. So let's take this point 1, 1 and see what we get. We get the answer 1 is greater than 1. Ask yourself this question. Is that true? The answer is no, it's not true. Therefore, we must use a dotted line. Now, any point above or below this line will work in our equation. Ask yourself, will points above or below this line work in the equation? The answer is above. So, when we draw the line, we do so using a dotted line, because any point on this line does not satisfy the inequality. What does, however, is any point in this entire area, anything above the line will work. So a point here, a point there, a point there, a point there. Any one of these points will satisfy this equation. Now, suppose we had a less than or equal to sign. Well, y is less than or equal to negative x plus 3. Let's try a point. We're just trying any point here. So I'm going to use this one here. I'm going to use this one here. So x is 0 and y is 3. Let's see what we get. 3 is less than or equal to 3. Is that true? Well, yes. It's certainly equal to 3. Therefore, we'll use a solid line. Any point, now is it going to be above or below the line that's usable in this equation? Well, honestly, if we're not sure, let's just try one out. Let's try 0, 0. Okay? So, 0, 0. If we solve this, we get 0 is less than or equal to positive 3. That's true. So we found our direction. It's anything below the line. Now, a little while ago, I said, get your equations in function form, right? Not general form and not something in between. Why does that make things so easy? Because this tells you exactly which way your answers are. If it's less than, if the y is on the less than side, then your answers are below the line. If your y is in the greater than, such as this, see y is on the greater than side, well then your answers are above the line. Okay, so make yourself a note to make that rule very clear, that little trick very clear. If you don't think you can remember that, or it's a little confusing, well then you can always try out a point just like we did here. We just tried out 0, 0. That's probably the easiest point to try out most of the time and see, does it work with the inequality or not? So let's move on. So, converting word problems into equations that we can work with. Well, this is clearly a very important task because most of the time when we get a problem on a real exam, it'll be in the form of a word problem. So what do we do? Here's our strategy. Step one, and I can't say this enough, is read the whole question carefully. So that doesn't mean skim the first and last line and try and get it in 2 seconds. Don't rush through these. Take your time, actually read every word. Step 2, identify your unknowns. That's what we do with just like we would with an inequality. So say, let x equal the number of so-and-so and y be blah, blah, blah. And then find out for yourself, what are we actually looking for here? So once you have these questions answers, things become a little easier. So, for example, the length of a rectangular plot of land measures 5 meters more than 3 times its width. Knowing the perimeter of the rectangle is less than or equal to 90 meters, find the maximal width for this plot. So, that seems like a lot of words, but let's break it down. First of all, this part here, we can turn this into a math expression. So the length of the rectangular plot of land measures 5 meters more than 3 times its width. So the length is equal to 5 more than translates to an addition, 3 times its width. 3 times its width. So just by doing that, I've identified my unknowns. In this problem, my unknowns are going to be length and width. So I'm going to make a little sketch for myself. Okay? Usually this is a very good idea. Kids just want to go right to the answer, but I prefer to make a little sketch so I know what I'm dealing with. So here, L length is equal to 5 plus 3W. So why don't I just write that, and now I have it all in terms of W. See how things are starting to get pieced together. Now let's use the second part. Knowing the perimeter of the rectangle. Well, perimeter of a rectangle, I know what that is. A perimeter, well, it's going to be the addition of all these sides, or the 2 widths plus 2 lengths, right? So make sure you're clear on that. So the perimeter of the rectangle is less than or equal to 90 meters. So this is going to be less than or equal to 90 meters. So I'll write that in. For perimeter, it's going to be less than or equal to 90 meters. So if the perimeter equals this expression, then I'll simplify this and just say 90 is going to be greater than or equal to 2W plus 2L. Now it's simply a matter of solving a system of equations. And do we need both coordinates in this? Ask yourself that. Do we need to find the width and the length? The answer is no. It asks find the maximal width of this plot. So here's L. L is equal to 5 plus 3W. So I'll rewrite this. And now I can solve. Put our like terms together. Again, bring the 10 to the other side, minusing 10 from both sides. I'll get 80. It's less than or equal to 8W. I'll divide both sides by 8. Now, notice I don't flip the sign at all. This is a positive number. If I was dividing by a negative number, sure, but this is a positive number. So I'll just get my answer. W can be anything less than or equal to 10. So the question asks, what is the maximum width this could be? Well, clearly for this, the maximum width that it could be is 10. So we have to answer the question. the maximum width is 10 meters. That is the largest number that would satisfy this inequality. So